Welcome to the Explainer. Now, if you work in IT, you know exactly what it feels like to manage a sprawling, chaotic web of networks, clouds, and apps. It's a lot. So today we're diving into a challenge that's absolutely critical, but honestly, incredibly fascinating. How do we take all those chaotic IT systems and actually unify them into a single, cohesive, self-correcting organism? Well, we're going to unpack the mechanics behind the SolveForce Unified Intelligence Architecture, and specifically, we're looking at its groundbreaking AI Pragmatics layer.
Okay, let's dive into this. Here's our roadmap for today. First, technology as a language. 2, the pragmatics of AI. 3, the digital helmsman. 4, the reverse forward model. And finally, number 5, the learning gate.
Section 1, technology as a language. To make these complex systems coherent, we really have to shift how we think about them. The foundational metaphor here is that we must treat technology infrastructure not as a pile of hardware and code, but literally as a language.
And this brilliantly illustrates exactly what that means. Just consider the sheer scale of the SolveForce architecture. It's an organized ascent. You see, it starts right at the very bottom with raw physical signals. You know, the literal zeros and ones passing through fiber optics. And then it builds upward, layer by layer, all the way to governed, intelligent action and coherence at the top. This quote really drives it home. Connectivity is language in action. We unify meaning across networks, clouds, security, and AI so your infrastructure thinks and acts as one. When you build coherence and ethics structurally right into the foundation, rather than, just bolting them on later as an afterthought, something amazing happens. All that operational drift, it just collapses into order. The systems don't decay, they actually get smarter and more unified over time.
Think of it like an ascent through these 5 pillars. The physical cables and signals, those are your letters. The networks connecting them, that's the grammar. Then the cloud and compute platforms that arrange those connections act as the syntax. Cybersecurity provides the semantics. It preserves the true meaning and integrity of the data. And finally, sitting right at the very top, AI is the pragmatics. It's the layer that takes all that meaning and actually applies action to it.
Which brings us right to Section 2, the pragmatics of AI. We are now at the very top of the stack. How does AI actually make decisions in a complex infrastructure?
To really get SolveForce, we have to contrast it with legacy AI. Legacy AI, well, it essentially guesses, right? It looks at patterns, generates a simple scalar confidence score, pulls the trigger, and then basically logs an apology after the fact if it messes up. SolveForce AI completely rejects that approach. Instead, it uses multidimensional calibration. It resolves the exact meaning, context, and intent, and it establishes a reverse trace before any action is ever authorized.
It pulls this off by building what's called a context graph across these 8 dimensions. So, when it builds this graph, it doesn't just stop at asking, hey, what is the entity? No, it asks about the topology, the time, the domain, and the intent. But the real game changer here? Authority. SolveForce explicitly demands to know who actually has the authority to approve this. And, maybe even more importantly, who can reverse it if something goes wrong. The AI literally cannot act without knowing its boundaries.
Let's apply this to a real-world term-to-action pipeline. Imagine an admin types restart the service. Now, we all know the absolute dread of a rogue script blindly rebooting a critical server on a Friday afternoon. But the SolveForce architecture locks that command down. It runs it right through this pipeline. It resolves the exact instance, the dependencies, the operational consequences, and the recovery path. It only moves to governed eligibility when it understands exactly, and I mean exactly, what restart means for that specific service in that specific context.
So what's the actual mechanism making all these complex, highly governed decisions? Let's get into Section 3, the digital helmsman.
The architecture relies on an ancient concept, Kybernetes. It's a Greek word that means helmsman. The AI here acts as a bounded digital helmsman. And notice that word bounded. The AI doesn't just blindly command the whole ship. Instead, it continuously senses deviations and makes bounded, highly calculated corrections to reconcile what is actually happening in the infrastructure with what the policy says should be happening.
But of course, this raises a massive question for anyone managing enterprise IT. How does this digital helmsman steer without crashing the entire system? I mean, we've all seen automated scripts go completely rogue and take down entire networks, right?
Well, it avoids crashing by using the 16-step recursive cycle. Think about the crucial phases here. Before it ever acts, it observes, establishes a baseline, and resolves the semantics. Then, and this is absolutely key, it simulates the effects. It compares the predicted, desired, and current states. Only then does it authorize an action within its bounds, measure the actual state, reverse trace the cause, and independently validate what it learned. It is an incredibly rigorous safety net. That idea of tracing things backwards brings us to Section 4, the reverse forward model. This is honestly one of the most mind-blowing architectural reveals in the entire SolveForce framework.
So the crucial point is captured right here in the bidirectional coherence axiom. Everything sent forward must remain verifiable backward. Simply put, an action cannot be authorized if its causal lineage and its governance lineage cannot be traced backward. No exceptions.
Let's look at the forward path, also known as operationalization. This is how infrastructure becomes intelligence. We start at the bottom with a measurable physical signal. Then we move up through permitted network grammar, into cloud syntax, resolve its semantic meaning, apply the pragmatic context, and finally execute a governed action.
Now let's flip the perspective and see how this builds in reverse. This is the reverse path, or substantiation. To prove that an action was valid, the AI must be able to trace it backward. It starts with the pragmatic action, traces it back down through semantic intent, syntactic system composition, grammatical permitted connections, all the way back down to the physical signal evidence. It demands hard physical evidence that the event actually occurred.
When the forward and backwards paths match exactly, when they converge, the action is substantiated, it's valid. But what if they diverge? Say the AI sees an action but can't find the physical signal, or vice versa. Well, that is a coherence defect. The system flags it instantly, catching errors way before they can turn into massive disasters.
But how does the system actually get smarter from all this? Let's move to Section 5, the learning gate.
Treating all errors exactly the same is incredibly dangerous. If a physical cable gets unplugged, that's not a policy failure. So the SolveForce system decomposes deviations into 7 specific error types. A semantic error requires a totally different fix than, say, a pragmatic error or physical disturbance. By categorizing them correctly, the system routes the error to the exact mechanism that needs to be fixed.
Once an error is identified, it enters the learning gate progression. An anomalous result doesn't just instantly rewrite the system rules. That'd be chaos. Instead, it becomes a lesson candidate. It undergoes that strict reverse causal reconstruction we just talked about. Then it requires independent validation, often from an out-of-band monitor or even a human being. Only when it's fully validated does it become an approved learning object that finally updates the codex, policy, or runbook.
Which brings us to the absolute golden rule of this architecture. No direct automatic updates from an anomalous result, period. The system is explicitly, technically prohibited from rewriting models or runbooks without that independent validation. This is exactly how you prevent AI from accidentally learning its way into a massive system failure. And to guarantee this rule is never broken, the architecture uses a strict separation of duties. There are 9 specialized deliberative agents. They handle interpretation, calibration, conflict, they argue, they interpret, but guess what? None of them pull the trigger. That is left to one completely separate operational agent. Deliberation is totally divorced from execution.
I'll leave you with this final, provocative thought directly from the architecture's core principles. Every action requires consent. Every word connects. Every mind understands. Just take a moment to consider what your own IT infrastructure could achieve if it stopped operating as isolated, chaotic silos and instead communicated with this level of unified, governed intelligence. Thanks for joining us on this explainer, and keep exploring.